We're going to have a look in this short video at the gradient intercept formula for a line, which we've already had a look at before, but we'll have a further think about this very useful way of describing a line. Let's have a look first of all at this set of 5 lines here. They all have formula that begin with y equals 2x. Now, if you remember from our discussion of the gradient intercept formula before, this number here in front of the x tells us the gradient of the line, the slope of the line, in other words. And in fact, if I look at the line down here and draw a little triangle underneath it, as we've learnt to do, I can see that the rise of a triangle underneath this line would be 2 and the run 1, so it has a gradient of 2. And all the lines that are here in this diagram would have the same gradient. And I can tell that by doing little triangles under each of them, but I can also tell it because they're all parallel to one another. So any line that has the same gradient as another line will be parallel to it. So the other thing that we notice about this set of lines is that they all cross the y-axis at different points. So the y-intercept for the dark blue line here is 2, so it has a formula y equals 2x because it has a gradient of 2 plus 2 because it goes through the y-axis at 2. Let's have a look at the green one. It also has a gradient of 2, but it crosses the y-axis at 1. So it will have a formula y equals 2x plus 1. 2 tells me the gradient, and the plus 1 tells me it crosses the y-axis at 1. And if we just keep going, this line here crosses at 0, so it has a formula of y equals 2x, which is effectively y equals 2x plus 0. We just don't bother writing the plus 0. Here, the light blue line, y equals 2x minus 1, because it crosses at minus 1, and the purple line, y equals 2x minus 2, because it crosses at minus 2. Okay, that's an interesting set of lines. What would it look like if we had a set of lines that all crossed the y-intercept at the same point, but had different gradients, so the slopes were different? We get something that looks like this. Here we are. These lines all pass through the same point on the y-axis, the point 1. So if you notice, they all have plus 1, plus 1, plus 1, plus 1 at the end of the formula, but each line very obviously has a different gradient. So this red line here, for example, if we drew a triangle underneath it, we would get a rise of 2 over a run of 1. So it has a gradient of 2, y equals 2x plus 1. So there you go. That's just an interesting way of looking at different sets of lines. Let's have a look at some examples. So as we've stated before, y equals mx plus c. I think we've been calling it b in our notes beforehand. It doesn't really matter. It's called the gradient intercept form of a straight line. And if we have a formula for a line that looks like this, y equals something times x plus something, then we can go to this number here before the x and find the gradient of the line, and go to this number here by itself, and that will be the y-intercept. So it's nice and easy to find those things. Let's look at some examples to make it a bit clearer. Here's an example here, y equals 2x plus 1. And the question is asking me just to state the gradient and the y-intercept for this formula. Well, because it's in the form y equals something x plus something, which we call the gradient intercept form, I can go straight to this number here in front of the x, which is actually officially called the coefficient of x, and that will tell me my gradient. So m, remember m stands for gradient, equals 2. And if I go to this plus 1 here, that tells me that it crosses the y-intercept at 1. Crosses y axis at 1, or another way of saying it is to call it the point 0, 1. Okay, so that's not too bad. Let's have a look at this one here. Y equals negative 3x. First thing we notice is it doesn't have a plus anything, so that tells us that it goes through the y-intercept at 0. Through the y-axis at 0. In other words, it passes through the point 0, 0. Sorry about that. The phone rang. So we know that this line here, y equals minus 3x, passes through the y-axis at 0, and the other thing that we can tell from this is that it has a gradient of negative 3. So it's nice and easy. If the line's in this format, y equals something x plus something, then we can just go and get those two qualities of the line, the gradient and the y-axis. Okay, here's another example. It's asking us to find the gradient and the y-intercept for these two formula and then to sketch their graphs. So let's have a look at that. First we'll do A. We can see straight away that it has a gradient of 2, and we can also see straight away that it has a y-intercept of minus 1. So to graph it, the first thing I will do is plot the point 0, minus 1, which is its y-intercept, and then I'll I'll just go and get a pen to do that with. Point 0, minus 1 is right there. Try and make it a bigger dot so you can see it. 0, minus 1. So that's the first point on our line. The other thing that we know about this line is that it has a gradient of 2. So that tells me that for every unit I go across or along the x-axis, I go up 2, up the y-axis 2. So my next point on the line is that point there. I could do that again if I wanted to. I go across 1 and up 2, because it has a gradient of 2. So that means that any triangle underneath that line has to have a rise of 2 and a run of 1. So 3 points is enough. In fact, 2 points is enough to draw a line, but we did 3 just to be sure. I can now join those dots together, and that gives me my line. I'll put arrows at the end to show that lines go on forever. And the other thing I always do with a line is to label it. So I type in the formula y equals 2x plus, minus 1. Alright, so that's the solution to part A of that question. Part B is a little bit different, isn't it? If we have a look at this formula here, it's not in the gradient intercept format. In other words, it doesn't say y equals something times x plus something. It says x plus 2y equals 6. So before we can discover the gradient and the y-intercept, we need to do a bit of rearranging. So let's have a look at what I mean by this. Yep. Equals 6. I want to rearrange it so that eventually it says y equals. So what do I need to do to rearrange this formula? Well, let's start by getting this x over to the other side of the formula. So we can do that by subtracting x from both sides. If I subtract x from that side, oh, that's right, my thing's broken. If I subtract x from this side here and subtract x from that side there, my formula then becomes just 2y equals 6 minus x. And because I'm used to having the x value before the number, let's just turn that around. 2y equals negative x plus 6. Okay, so we're getting there. We still have this thing in front, times 2. We're timesing the y by 2. So we need to divide both sides by 2. So if I divide 2y by 2, I just get y. If I divide negative x by 2, I just get negative a half x. That's not written very nicely, but I'm telling you that's what it means, negative a half x, plus 6 divided by 2 is 3, of course. So if you have a look now at what we've got, we have rearranged that formula into the y equals something x plus something, and so now we can say that the gradient of this line is negative a half, and the y-intercept of this line is 3. Y-intercept, sorry, can't type, is 3. So let's go and do some plotting. We'll use a different colour. How about bright red? My y-intercept is 3. I go to the y-axis and go up to the point 0, 3 there. I'll put a nice big dot so you can't miss it. Now my gradient is negative a half. So when I have gradients of fractions, a nice way to think about it is it's giving me already the rise and the run. Oh, sorry, it's really hard to write. Pretend that's a 2. So my rise is 1 and my run is 2, and it's going in a negative direction. So remember, negative lines go that way. So if I go across 2 for the run and then up 1 for the rise, I get a new point there. And I could do it that way as well, a run of 1 and a rise of 1 and a run of 2 gets me to that point there. And there's my new line. Let's go and draw it. Let me just go, it's purple, through those 3 points there, chuck arrows at the end, and of course we also label it And it doesn't matter whether I write y equals negative a half x plus 3 or x plus 2y equals 6. Equals 6. There we go. Okay. So that question was a bit more complex, mainly because of the algebra that we had to do to rearrange it. What's the next one? Same question. Alright, I'm going to leave it there. We'll come back and do this example in a minute. What I'd like you to do is to go and do some questions from exercise 4F, but don't do the questions that ask you to decide whether a dot is on a line. We're going to do that in the next video. So exercise 4F, but don't do the questions that ask you to find out if a dot is on a line, a point is on a line. Okay, have fun. Bye.